Welcome guys. In this video, we're going to be learning numbers, maths, IGCSE 0580. And the topics we're going to be covering today are from C 1.1, which is the core syllabus, and E 1.1, which is the extended syllabus. And both of these are the same, so both students need to learn these basic concepts. And it's all about numbers, types of numbers, and let's kick things off with what we're going to be learning today. So we're going to be learning natural numbers, integers, prime numbers, square numbers, cube numbers, rational, irrational numbers, as well as reciprocals. There are two topics in this that we are missing, and those are common factors and common multiples, HCF or LCM, and I'm going to be covering those in a separate video because those tend to be kind of tricky for some people, especially to remember them and to use them or to use tricks to find the HCF and LCM in exams. So I'll be covering it in the next video. Now, let's start off with natural numbers. Natural numbers are numbers that you use in your everyday counting. So that's going to be 1, 2, 3, 4, on and on. Now, one thing to note in this is that 0 is not a natural number in this syllabus. However, in real life, it's kind of conflicted because it is a whole number. However, in our syllabus, IGCSE 0580, we're not going to be counting 0 as a natural number. Now, natural numbers are only whole numbers. So, 3.6, anything with a decimal is not a natural number. So, 3.6 is not going to be a natural number. Anything that is negative, like -4, is not a natural number. And yeah, that's the gist of it. Positive numbers, whole numbers, are natural numbers. So, like anything from like 1300 or 1419, all of these are natural numbers. Now, moving on to our next topic or subtopic, should I say, integers. Integers. So, these are also whole numbers, and these can be positive, negative, or 0. So, let me just write that: positive, negative, or 0. So, 3 is an integer, 4 is an integer, -6 is an integer, 0 is an integer. However, again, anything with decimal points breaks the first rule, so decimal points not allowed. So that's actually pretty easy. Uh, let's move on to our next topics. And yeah, you might be thinking right now that this is very easy. However, in the exam, they might ask you give the answer like in the nearest integer or nearest natural number or nearest square. So they tend to try to put a twist on the questions. And even if you did the question correct, if you're not giving it to them the way they want it, they will be reducing marks. However, you will get some marks for the working you did because your answer technically is correct. So, the next thing we're going to cover are prime numbers, and I am sure everybody knows that, at least I hope everybody knows them. Prime numbers. Now, prime numbers are basically natural numbers. So, -4 is not a prime number, -3 is not a prime. Negative numbers or 0 are not prime numbers. So, a prime number is basically a number that is 1 or greater than 1. Sorry, not 1. 1 is not a prime number. Please remember that. 1 is not a prime number. Neither is it composite. Composite is the opposite of prime. So, like a prime number has two factors. So, let's take the example of 3 here. It has two factors, which is 1 and 3 itself. 1 and itself. So, the only two factors a prime number will have is 1 and itself. So that's pretty easy. Another trick is that 2 is the only even prime number. So any other even number other than 2 are all composite. So that's a quick trick. If they ask you what's the only even prime number, just have it on your fingertips. So yeah, moving on to the next topic, square numbers. So square numbers are pretty easy. They are basically when a number, let's take 4 for an example, 4. There you go. 4 is multiplied by itself two times. So that's 1, that's 2. 1, 2, yeah? So we would write this as 4 squared to the power of 2. This is because 4 is multiplying by itself two times. That's 1 and that's 2. So hence we write 2 and that's squared. So that's basically the only thing there is to square numbers. So like you can have n squared. N squared is basically n multiplied by itself two times. And this comes across, and you will come across this concept a lot in algebra. So it's good to remember that. So let's go back to example here. 4 squared. This is gonna equal to 16. So if we just pull up our calculator here and we write 4 squared, you're gonna get 16. So that's basically what it's doing. It's multiplying 4 by itself. So let's multiply 4 by itself over here. 4 by itself multiplied, that's 16. See, so that's basically what square numbers are. Moving on to cube numbers. These are basically this somewhat of the same thing, and they're basically when a number, let's take 4 again, multiplies by itself three times. So that's 1, that's 2, that's 3. Okay, so I'll just show you a quick example. If 4 times 4 times 4, we get 64, right? So that equals to 64. We can also write this as 4 to the power of 3. That's right, 3. So if we put this into our calculator, 4 to the power of 3, we get 64 again. So this basically shows that this number basically uh, shows us how many times the number is multiplying by itself. So this also is going to equal to 64. Now if we have a number that's multiplying by itself like 5 times, so let's say like 4 is multiplying by itself 5 times, we don't have enough time or enough energy to write all of that. Yeah, and then if imagine you have to take it to the other side to divide it. That's too much of a hassle. All you gotta do is write 4. Let me just write it down there, you might not see it there. 4, how many times is multiplying? 1, 2, 3, 4, 5 to the power of 5. It's that simple. In this case it multiplies by itself 3 times. In this case it multiplies by itself 2 times. I hope that's clear. Okay, so the next topics are actually common factors, HCF and LCM, and I'll be going through those in a separate video as I have my own tricks and tips, so that can help you in your exam. So I'll make an entirely different video on that, and I'll have that linked in the description, or you might see it on the top right. For now, we'll just go to our next topic. We have rational numbers and irrational numbers, basically two sides of the same coin, you could say. Now, a rational number, the definition is kind of tricky, but I'll just do my best to explain it to you in a different way. These include all integers. These include all uh, terminating decimals, terminating decimals. What those are basically numbers that have decimal points like 3.643, but the decimal point comes to an end over here, so it doesn't move further from there. That's all it goes. There are some decimals that are non-terminating, and those go on forever and ever and ever, like pi. So if I just put input pi over here, and what is it equal to, it gives us pi. That's because this number goes on infinitely, and it's basically roughly 3.142. We use this value. So basically 3.142 is the number pi. It goes on infinitely and infinitely, never stops, and it is also not repeating. And here we get to our next point. Rational numbers include decimals repeating decimals. So basically what these are infinite numbers that go on forever and ever and ever. However, they're repeating. So 1.15, 1515, like it just keeps repeating. We'll just keep those two dots. These two dots mean that these two numbers repeat on and on forever. So then it would go on, it would be 151515 forever. Okay. So these numbers, repeating decimals, are rational numbers, even if they're not terminating. So I hope you get the gist of that. And let me just give you a couple of examples for rational numbers. We have 1 over 4. 1 over 4 is what? 0.25. Yeah? So that's what a terminating uh, decimal, right? And another example we have is 0.75, negative 5, negative 3, 0, a million, 1000. So all these are counted as rational numbers. So irrational numbers are basically those that are non-terminating, like our friend pi over here, never ends, and they're also non-reoccurring. So unlike 1.1515, this does not ever have the same pattern of numbers, and pi is also another example of that. The pattern of numbers after 3, like after the decimal point, never repeat itself. So there are an infinite number of possibilities that this can form. The number pi after the decimal, since values don't repeat themselves, your let's say your birthday will be in the number pi. So you can find, like, after probably a million decimals or 2 million decimals, that your birthday will be there. So if you're born on 1st June 1st, let's say you're born on June 1st 2007, 112007 will be there somewhere. So like 112007, it will be there somewhere. This is basically the magic of the number pi. However, you don't need to write that in the exam, don't worry. So another example of irrational numbers are surds, and this is a topic that we'll cover further in our syllabus. And basically what these are roots that uh, are not terminating or not reoccurring. So let's say the root of 2, this is a surd. So basically any number that's not a perfect square makes a surd. So let's take the example of 5. Is 5 a perfect square? No. Let's take the example of 4. Is 4 a perfect square? Yes, it is. What is it divisible by? It's divisible, like the square of 4, it's 2. So we're gonna get 2 for this, and 2 is back to rational numbers. So this is not an irrational number. This is, and this is. So I hope you understand that. The last topic of the day are going to be reciprocals. Now, these tend to get a bit tricky, but I really don't see how students find them tricky. It's basically that if you have a number, let's take 4. You have 4. You want to take the reciprocal of that. We're gonna get 1 over 4. If you're asking why would you need to take the reciprocal of that, hold your horses. We'll get to that point. You got 1 over 4. That's basically how it works. It's a number divided by 1. So 1 comes on top of that. It's that easy. And some of you may not know, but if you have a number like standalone right there, it has a 1 under it. The numerator is always 1. So we're just gonna flip that, and we're gonna get 1 over 4. So let's say we have a over b. Let's say we have a fraction instead of a whole number. This is gonna be the same. It's gonna go there, that's gonna go there. B over a. That's the reciprocal. However, if you have an equation, let's say a equals to b over c, right? And you want to take the reciprocal of that, you can flip this and you can flip this. What's that gonna give you? C over b, right? We also have this dude here. If you take the reciprocal of one side, you're gonna have to take it for the other, because these two are equal, right? So whatever you do there, you have to do there. You plus one there, plus one there. So it's basically the same thing. Remember what you talked about? The one goes on top, a comes on bottom, there's the equal. That's the reciprocal. And why you would need to use this, I'll just give you a quick example. If you have uh, a number, let's say 3 divided by 5, divided by 1 over 3. What you're going to do over here is basically take the reciprocal of this number, right? And then we can change this into multiplied. So we have 3 over 5 multiplied by 3 over 1. That's a whole lot easier than this, right? So that's basically one case where you can use reciprocals. And here you might be confused why we're not flipping both of them. That's because these two are not equal to, we're dividing these, right? So if these were equal, we would flip this one as well. But this is not equal, we're just dividing. We want the sign to change, so it becomes easier for us. So we flip one side and we can make it multiplied. You can also flip the other side if you want. So that's going to become 5 over 3 times 1 over 3. That's not as easy as 3 over 5 times 3, right? So yeah, that's an example of where we use reciprocals. And just remember, if you're any what confused in all of this, drop a comment. I will reply right away as soon as possible. Trust me, that's my word. And if you have any questions you would like to ask me, again, comment section is kind of free. So message me there and I will do my best to reply. Until the next one, see ya.